the revision of Unit 4 Sequential Logic Circuits. So it consists of flip-flops, registers, counters. What is a flip-flop? It is a sequential circuit capable of storing one bit of data. So either it can be 1 or 0. Okay, so how to trigger a flip-flop? Either it is a positive triggered or negative triggered. Okay, so this is a positively triggered pulse. Okay, this is represented by a triangle, this triangle. A negatively triggered pulse, that is from, it comes from 1 to 0. Okay, that is negatively triggered pulse. So that is, here there is a bubble inside. Okay, so here it shows us the positively triggered pulse. For that we put a one-day triangle. For a negatively triggered, we put a triangle with a bubble. Okay, so now we'll move on to flip-flops. So this is an SR flip-flop. Here S stands for set and R stands for reset. So this is the logic circuit diagram using a NAND gate. Okay, don't forget to put the bubble here. Okay, here in SR flip-flop, so if there only there is a clock, and only if there is a 1 in S1 and R0, only for this combination the flip-flop is in set position. Okay, so only if this combination, see, S is equal to R1 and R is equal to 0. For all others, if the clock must be there, and if there is a 0 in S and R is there is a 0, then there will be no change. If S is equal to 0 and R is equal to 1, then it is in reset position. If S both are 1, then it is a forbidden state. Okay, if no clock is there, then no action is taken. Okay, so here if you know the timing diagram, okay, so here the S is 1, it's moving from 0 to 1. Here it is from 1 to 0. So in this position you see the R is 0, the S is 1, but the clock is what? Positively triggered. So the three conditions are satisfied here. So it is in set position, that is the Q goes from 0 to high position. Only it is high here. So fully it is high here. Then here the S goes low. When S goes low, 0, then automatically the Q goes low. Okay, in Q bar it is a complement of the Q. So whenever there is a high, you put a low here. Whenever there is a low, you put a high here. So that is the timing diagram of SR flip-flop. The JK flip-flop, so here J is there, K is there, and here there's a positive triggered clock. So only the triangle is there, Q bar is there. Okay, so here you see a change in the circuit diagram. One K is the one input of K goes to Q, and then one input of J, it goes to Q bar. There is one thing, and then the clock, it is triggered by a positive clock. Okay, so here same like SR flip-flop, for 0 0 no change. For 1 0 there is a set position, 1 0, here also 1 0, and there is a set position. For 0 1 0 1 there is a reset position, and for 1 1, so there is a change from RS flip-flop. So here comes the toggle. Toggle means if it is in one state, then it will toggle to 0. Okay, so if there is no clock, then no change. Okay, so here we see the timing diagram. It is same like SR flip-flop up to this point, Okay, so here the clock is positively triggered, this point positively triggered. Here J is 1, okay, K is 1. Okay, that means it should toggle. The already value exists is Z1, so now it toggles to 0. Okay, so this is the Q, and you can draw the Q bar easily. So already this is 0 1, so how it goes? So you can draw like this easily. It's a complement of Q, that's all. Okay, so any other thing, like here we see, here J is 0, here K is 1. So what should be the Q? Here we see J is 0, K is 1, so here it is 0. So here it is 0. Okay, likewise it goes, but here J is 1, positive triggered, this point positive triggered, J is 1, K is 1, so it just toggles. Okay, so that's how it goes. And then we have D flip-flop, in D flip-flop, so this is a circuit diagram, only the one input is there. So here it is very easy. So clock is there for 0, Q is 0, it is in reset. For if clock is there, if D is 1, Q is 1 and it is in set position. Okay, so if clock is 0, no change. So it is very easy here. So here there is a positive transition, 1 is there. If 1 is there, then from 0 it moves to 1. Okay, thank you.